In this video, I'm going to show you how to find the magnitude and direction of a vector given its components. Let's consider a standard xy axis. We'll draw some vector r that makes an angle theta with respect to the x-axis. This angle is important because when we find the magnitude and direction of the vector, we will talk about its direction in terms of theta above the x-axis. To find the magnitude of the vector, we need to know its components. And since this is a two-dimensional vector, we have it in x and y direction, we'll need the two components. It has a y component of 2.5 with units of length. Those could be meters, centimeters, anything that can measure length. And it's going to have an x component of 5. Now that we know those components, we have enough information to find both the magnitude and direction of this vector. First of all, the magnitude. This should remind you of a triangle. In fact, it should remind you of a right triangle, to be specific. We can find the hypotenuse length of this triangle given the length of its other two sides using the Pythagorean theorem. So we'll have r, the length of our vector, equals the square root of the sum of the lengths of the other two sides. So my x side and my y side. And if I really wanted to be precise here, I should call these r's x component squared and r's y component squared. We can go ahead and plug in the information we have to find the length of the vector now, its magnitude. My x component is 5. My y component is 2.5. And if I square these and add them together, I get 31.25. If you want to take a second pause and check that I did that step correctly, go ahead and do that now. And when I take the square root, before I write down the answer, I'm going to give you some intuition here. 31.25. Well, I know that 6 squared is 36, and I know that 5 squared is 25. So I would expect the square root of 31.25 to be somewhere in between 5 and 6. And if I grab a calculator and check it, I get 5.59, which is right between 5 and 6. So my intuition worked out there for me. This is how you find the magnitude of the vector. Right here. Now let's work on finding the direction of the vector. All I need to answer here is what is theta? Because if I can tell you what theta is, I can say this vector points at a certain angle above the x-axis. Well, remember this is a triangle, a right triangle, so we can use some basic trig functions to find this. And at this point, we know the lengths of every single side of the triangle, because we found that the hypotenuse is 5.59. So we could in fact use any trig function here. We could do sine, which will give me opposite over hypotenuse, or in this case, since we're concerned about the angle theta, that would give me 2.5 over 5.59. We could use cosine theta, which is adjacent over hypotenuse, which in this case, adjacent would be the one next to the angle, so 5 over 5.59. Could use either one of these, or I could even do tangent, which is opposite over adjacent. And in this case, that would be 2.5 over 5. Tangent makes the most sense to me here because I was given 2.5 and 5. So if I made some kind of mistake in finding r, that error won't propagate if I find my angle with tangent. And the error won't propagate because this was given information. can use any of these because I have all the information for them. I'm just going to use tangent because in my mind it's the safest, because I won't be propagating any error if I messed up in finding this r. So let's use tangent to find this. Tangent theta is 2.5 over 5. So I need to take the inverse operation of tangent on both sides of this equation here. So to write that out, I want to take the inverse tangent of the left side, and the other side of my equation, I want to take the inverse tangent of 2.5 over 5. Okay, inverse tangents cancel, and now I have theta equals the inverse tangent of 1/2, or 0.5. And if I grab a calculator to figure out what the inverse tangent is of 0.5, I find out it is 0.464 radians. Now, if you get a number that's wildly different than my number, it probably means your calculator is set in degree mode, so you want to change it to radians and then check my answer. That is how you find the magnitude and direction of a two-dimensional vector.